So that's pretty good. There's a couple of things that we want to do. First of all, we want our tanks to be a different color. So one thing that we want to do is we want to adjust the color of the individual tanks. Now, as we saw, if we change the tank chassis, or even if we come in here on the tanks and we change any of the things about the tank chassis, then it's going to change all of the tanks. Now, if we change it right in here while we're running, I'm not sure if that will necessarily be the case. Oh, it will, yes. So all of the tanks change because they all share the same material. And that's not what we want. We want to be able to specify different colors for the tanks. So let's stop running. Tank chassis, and that change actually persists beyond the stopping the play mode. So let's bring our tank chassis back to a green color again. So what we're going to want to do is we're going to want to be able to change the material color on individual tanks when they are created. So one of the things that we're going to want to be able to do is we're going to want to be able to just say set color on a tank and not have to worry about setting the color, our tank spawner, for example, having to go and set the color of each individual piece of the tank. So what we're going to do is we're going to actually create another script to be a tank. So we're going to create a script called tank. Tank is a new mono behavior. And right in here, I'm actually going to go ahead and drop that tank right on top of the tank script, right onto our tank prefab. So now if we look at our prefab, it now has the tank script on there. The script doesn't do anything right now, but we have that script. So now if I double click on tank, we can reload our project. Okay, so now here's our tank. Now, fix up some of these line endings again so my OCD doesn't go crazy. Boop, boop, boop. Okay, so now we have our tank model behavior in here. Now what we're going to want to do is we're going to want to have a function in here, a method. Again, we're not going to be using update, so I'm just going to get rid of update. We're going to want to have a method in here that we're going to say is public, so other things can access it. Void is not going to return anything, and we're going to say set color. To my Canadian friends, I apologize for my spelling of color, but given that C# spells color without the U, I just find it a lot easier to keep track of if I just stick with the American spelling all the time. So, in set color, we are actually going to want to set the color of the material of the tank's mesh renderer to whatever color we pass in. So we're going to want to pass in a color. We're going to say color tank color. So now there's a couple of ways we can actually do this. One way is right here in set color we can actually say get component, and we can hand it a generic parameter of mesh renderer. Oh, sorry. No, first of all, we need to actually get at the individual pieces. We need to get at, we know that our tank, here, let's drop a tank into our scene here. So we know our tank is made up of, here we go, a body, a dome, and a gun. So, there are a couple of ways that we can get at those particular children. We can actually go and find them as children, as named items, or we can expose them in our tank script, and we can actually just set them right in the inspector. That's my preferred way of going, because find can be a bit of a slow operation. It's okay if you only do it once on the creation of an object, say, as long as that object isn't spawned over and over really, really quickly. But as it exists right now, we probably could just go and find those objects that we want. But instead, what I'm actually going to do is I'm going to come back here, and I'm actually going to say public game object tank body, public game object tank dome, and public game object tank gun. So in here now, if we come back into Unity, I can actually see on the tank, once it finishes compiling, on the tank I can see the body, the dome, and the gun. So I can actually go and drop its own body right on here, its own dome right on here, and its own gun right on here. You can see they're bold. That means that something is different from the prefab. But we actually want this to hold true for all the prefabs. So we're going to apply, and now it's no longer bold. So now the tank knows about all of its individual parts. So in our script, we can say, when we set the color, we can say tank body dot get component, and we're looking for a component of type mesh renderer. Then we can, off of mesh renderer, we can actually get at the material, and that's the first instantiated material assigned to the renderer. And then we can say dot color equals tank color. So then we can do the same thing for our tank dome. Mesh renderer dot material dot color equals tank color, and tank gun dot get component mesh renderer dot material dot color equals tank color. So there's our set color function. So now in our tank spawner we can actually set some colors. So let's actually expose some colors. So let's make a public array of colors, which we're going to call tank colors. I'm going to give that a capital because it's public. Okay, so now our tank colors array, we have an array of tank colors, and so in our little loop here, we're going to say if tank colors dot length is greater than 0, and that's just to make sure if we forget to set some colors, we won't be getting null references or anything like that. If our length is greater than 0, then we want to say that new, first, actually what we're going to do is we're going to say, right here, we're going to say tank, new tank, equals new tank object dot get component called tank, or of type tank, I should say. So we're going to say, we're going to get our new tank, and then in here we're going to say new tank dot set color to tank colors, and it's going to be I modulo tank colors dot length. And what that's going to do is it's going to make sure that if we set fewer colors than we have tanks, that will wrap around in the list. So we'll always have a valid color that we can set. So we'll save that. So now if we come back out here, let's get rid of the tank that we just have hanging around here in the scene. As soon as things are done compiling, here we go. Get rid of that tank. So now we have on our tank spawner, we have a tank colors array. So we can actually set this to a size. So let's set this to 5. And then that lets us actually choose some colors. So let's say first player is red, second color is blue, third color is yellow, fourth color is going to be bright green, and the fifth player is going to be sort of a magenta pinkish color. Okay, so now we've got a bunch of colors on our tank spawner. We have 5 colors, we're trying to spawn 5 tanks. So now what we should see is 5 tanks of different colors. And that's exactly what we wanted to see. Now I'm going to make a little modification to our script. Because our tanks would be fighting each other, we actually also would like it if they had a rotation that wasn't all, so they weren't all looking one way. So what we can do is we can say float y rotation equals random dot range 0 to 360. This is in degrees. And we can say quaternion rotation equals quaternion dot angle axis. So that lets us provide an angle, which is the random value that we just got, and the axis about which we want to rotate, which in our case is going to be vector 3 dot up. So that's pointing straight up in the y. And then we can say new tank object dot transform dot rotation equals rotation. There we go. So now we have this little modification made. If we hit play, now our tanks are all pointing in different directions. And let's just make sure that our logic was okay with the number of colors. So if we say we want 15 tanks instead of 5, we should get 15 tanks, and the colors should all wrap around. There we go. So we have 3 of each color now. Now you can see some tanks ended up on top of each other, right over here and right over here. That's something that somewhere down the line we're going to need to fix. We don't want tanks to land on each other, so just randomly scattering them about a given space is not going to be good enough. We're going to actually have to worry about the distribution of tanks and try to get some sort of a normalized distribution or a regular distribution throughout our space. Now there's one, there are a couple of little gotchas that I wanted to discuss just before I leave this. This is going to be the last thing for this stream here today. One of the things that I wanted to talk about was the difference between material and shared material. Now it might seem obvious from the name, but I've seen this trip people up before. So if instead of setting the material on those tanks, I set the shared material on the tanks, then what you will see happen when we come back over here to Unity is when we run, we now have a whole bunch of tanks that are the last color that we set any tank to. And that's because we've set the shared material. So the shared material is essentially the actual tank chassis material. We've gone and we've actually set the tank chassis material to have that value, and all of the tanks are actually sharing that. So now if we go and take a look at tank chassis, now it's actually pink, because through code we actually literally went, grabbed that shared material, and changed its color. What's happening when we actually, let's go back to this being material, we save that. So now, when we come in here, we can actually say play. Now, each one of our tanks, you can actually see under materials it actually says tank chassis instance. Tank chassis instance here. So this instance of tank chassis is red. And if I go under this one, this instance is blue. The reason for that is that when you access the material on a given mesh renderer, when you access the material for the first time, nothing special happens to it. But as soon as you try to change something on the material, so as soon as you say material.color equals, for example, or try to make any other change to the material, then this is actually going to cause a new instance of the material to be created. That's something to watch out for. In this case, it's exactly what we want. We want every tank to have their own instance of the material so that we can set them to whatever color we want. But you have to be careful, because if that wasn't what you intended, if you intended to have a whole bunch of tanks that looked exactly the same with the exact same texture and color on them, and then you went setting the color of the tanks via material, or any other aspect about the tanks for that matter, then by doing this, you're now creating extra materials, which means you're using up more memory, and it may become a little bit more confusing to keep track of what's happening if what you had intended was for everything to stay the same. So that's one thing to be aware of. Now the other thing that I wanted to talk very briefly about is what we're doing right here. So right here, where we're setting the color here, we are actually going and we're getting the component every time we set the color. Now we're only setting the color once, and that's in this start method right here. And so that actually is pretty okay. In Unity 5, and actually in Unity 4.6 and earlier, using getComponent in general is not that bad. In Unity 4.6 and later, sorry. But in older versions of Unity, getComponent was actually a very expensive operation. It didn't have any caching associated with it or anything. And so it was actually quite expensive to do this if you were going to be, say, setting the color of the tanks more often. So something that you would want to do would be something like this. You would actually say mesh renderer, tank body renderer, mesh renderer, tank dome renderer, mesh renderer, tank gun renderer. And then what you would do is you would actually, let's copy these, paste. So then you would actually say this equals that, this equals that, and this equals that. So then, going forward, you already have a reference to the mesh renderer. Every tank has a reference to its own mesh renderer, and there's no additional cost to accessing it. But I've actually done something that's very subtly wrong here, and this is why I wanted to bring this up, because this is another gotcha that gets people sometimes. As I said, getComponent is not all that expensive anymore, so you don't actually need to worry about premature optimizations like this as much as you used to. But this sort of idea of caching something out when an object, in an object's initialization, that's something that you might want to do from time to time with other elements, other fields on a class. So if I do something like this, it seems like, okay, as soon as the tank is initialized, then we'll have these things, and then we can go and set these colors. Well, let's try it. Let's see what actually happens. So we'll stop playing. We'll let this finish compiling. Now if I hit play, I actually get an error. And it's a null reference exception. Object reference not set to an instance of an object. It only created one tank, and then it hit this null reference exception and it died. It's giving us the line here, tank.cs line 24. So if we double click on this error, it's bringing us to right here, set color, tank color. Well, what's the problem here? The problem is that tank body renderer is actually not initialized yet. And the reason for that is we're creating the tank inside of the start for tank spawner. Start is a special function for mono behaviors that gets called on the first frame after a game object is actually active in the scene. But at this point right here, our tank hasn't been active for a frame yet. So we actually haven't initialized this yet. Now there's a couple of ways that we could deal with this. One way would be to actually change this to a calling start directly is something that you might think about, but I would recommend against that, because anytime you start manually calling functions or methods that are really meant to be or they're special to Unity, for example, they're special to a game object, you can run into some tricky situations where you get functions being called twice that you didn't intend to be called twice, and so on. So one approach would be we could actually change this to some function that's not special, like init. And then right here inside of tank spawner, we could actually say, after we've created our new tank object, and then we grab our new tank, we could actually say new tank.init. So now we know that, oops, I didn't make that public. Public. Save. There we go. So now we know that the new tank will be initialized before we get to the set color. So if we come back to Unity, let's clear that error out of our console. Nobody likes to see errors. Okay, so now if we hit play, everything works. There's another way we can go about this, actually. So if I come back here, and I actually get rid of this call to init, instead of init and instead of start, there's another function that Unity has called awake. Now, awake is actually called before start, and awake is called as soon as an object becomes active, not on the frame after it becomes active, or not on the first frame it becomes active. It's actually called at the moment that it becomes active. So there are different uses for awake versus start depending on exactly how you're going about creating your objects and so on. But as it stands right now, if we put that into awake instead, let things compile. Now if we run, everything works fine again, because awake actually does get called as soon as this tank object is instantiated. And so from then on, we now have a valid renderer object, and then when we call set color, we can safely assume that our renderer has been initialized. That's assuming that we found a mesh renderer component on here. But in our little demo, we've set things up such that we know there's going to be a mesh renderer there. So that's just a couple of little gotchas to keep in mind. So this kind of brings me to the end of the stream. This stream has been a whole lot longer than I had intended it to be. My apologies to, well, my one viewer at the moment live on Twitch. I'm probably going to split this up into multiple pieces before I put it up on YouTube. So if you're watching on YouTube, this might be the ending of, say, part 2, maybe part 3. In the future, I'm going to try to actually set a timer for myself and have more regular breaks in between the parts, so we can chop this up into something more bite-sized, more easily consumed on YouTube. But anyway, I hope anybody who's watched this has enjoyed my quick little demo into some Unity basics. In our next episode, we'll be taking this a little bit further, actually getting some code in there to let our tanks fire their guns and start getting some actual gamey elements into the game. Alright, thanks for watching. See you next time.